Today we're going to take a look at proving parallel lines. So when we first learn about parallel lines, we learn that parallel lines create certain kinds of angles within the image. So we're going to be kind of working backwards. I want to figure out what the measure of CBE is to make sure that R and S are parallel. So instead of saying parallel lines give us these angles, we say we have these angles. Now we have parallel lines. These angles are alternate interior angles. And alternate interior angles, if they are the same, you have parallel lines. So let's create an equation with those two. We say 5x plus 1 equals 7x minus 15, and we do our inverse operations. Minus 7x, negative 2x, minus 1 equals negative 16, divide, x equals 8. So we found x. Great, but we're not looking for x. We're actually looking for the measure of this whole thing. So I need to take this. I'm going to put it there. 5 times 8 plus 1 gives us 40, and 1 gives us 41. Now, I'm still not convinced that both those angles are the same. Let's take this 8 and also put it down here to make sure that that also is a 41. So we say 7 and 8 minus 15, which gives us 56. Minus 15 and 41. So since both angles are 41, this angle and that gives us parallel lines. Now we have a little more of a thought process to get there. I know we have a right angle here. That's what that little box means. That means we have 90 degrees. So by supplementary angles, this also has to be 90 degrees. And now, by alternate exterior, these two should be the same. So we can say 3y plus 30 equals 90. And let's do our inverse operations. 3y equals 60, divide by 3, y equals 20. Now we're looking for y to determine that that's going to be the same. If I take this and I plug that back in, 3 times 20 is 60, plus 30 is 90. And if you have two lines that are perpendicular to that same line, then it has to be that these are going to be parallel to each other. And that is proving parallel lines.